Problem number 13. Solution for this problem you can find in the reference below this video. A ball of mass m and radius r has a moment of inertia I equal 2/5 mr square. The ball is released from rest and rolls down the ramp with no friction loss of energy. The ball is projected vertically upward of a ramp as shown in diagram. Reaching the maximum height y maximum above the point where it leaves the ramp determines the maximum height of the projectile y maximum in terms of h. Solution. In this problem, the main key is that whole potential energy going for translational kinetic energy and rotational kinetic energy. And because there are no sliding here, we have always this relation when ball contact with the surface. Omega, which is angular speed, equal v over r. And it's equal to this expression even in the last point where this ball contact with the surface. So it means that before that potential energy going to translational rotational kinetic energy, and after that when the ball reach this point, only translational kinetic energy going to potential energy, but rotational energy is still the same. It's not using for increasing height, so force of friction is not helping us to reach the highest point. And in that case we need to do next steps. So first, potential energy mgh equal 1/2 mv square, which is translational kinetic energy, plus 1/2 I omega square, which is rotational kinetic energy. Now using this expression and the expression for I, we can insert them here and find finally that mgh equal 7/10 mv square. This is how to find the v square in this point of losing contact. In this point v square equal 10/7 gh. And now we can do a reverse problem, so we can find how is this translational energy going to potential energy. So here we have this equation: mgy maximum equal 1/2 mv square, and after when we put this v square from here, we can find that it's equal to 5/7 mgh. So it means that y maximum equal 5/7 h, which is answer D. Problem number 14. Solution for this problem you can find in the reference below of this video. A block with mass m1 equal 5 kilograms with the speed v0 equal 8 meters per second travels 2 meters along a horizontal surface where it makes a head-on perfectly elastic collision with the block of mass m2 equal 15 kg, which is at rest. The coefficient of kinetic friction between both blocks and the surface is μ equal 0.35. How far does the 15 kg block travel before coming to rest? Solution. So we need to split this problem for 3 parts. First part, it's we need to find what is the speed of the first block before collision when it travels 2 meters. Second part is to find what is the speed of second block after perfectly elastic collision. And third part is find what is the distance second block travel after this collision. Let's do it step by step. So first step, we have equation. So we have this equation, initial kinetic energy equal final kinetic energy minus work done by force of friction. So that will be this expression. And we can find what is V1 square from here. This expression. Now we have absolutely elastic collision of two blocks with mass m1 and m2, and this is a very well known problem when one block is at rest and other is moving to it, and it has a perfectly elastic collision. For the second block we have speed equal this expression. You can find it using center of mass frame reference. And the last step to find what is total distance to travel for second block when initial speed is v2. This we can find from energy formula. So we have total kinetic energy going to work done by force of friction. And after that, when we count what is x, we can use all this data to completely count it. That will be this expression. And after we put all numbers, we will get around 1.79, which is answer B.